If you enjoy our content, please remember to like this video and subscribe to the channel. We'd love to hear from you in the comments. Let's start with a question. What would you do if a real zombie outbreak happened? The idea of a zombie apocalypse is a staple of fiction. A thrilling thought experiment explored in movies and books. Yet in nature, a version of this story plays out every day. Not reanimated corpses, but subtle, chilling manipulation. This is the world of neuroparasitology. Parasites that control the nervous systems of their hosts. Tiny organisms that alter behavior in profound ways. They turn hosts into vehicles for survival and reproduction. These aren't movie monsters. They're products of millions of years of evolution, with strategies exquisitely tuned to their hosts. A worm might compel an insect to seek water, an environment it would normally avoid, all to complete its life cycle. Long-term control often comes from secreted chemical compounds acting on genes and signaling pathways, changing how genes are expressed, to produce lasting effects on behavior. The host is no longer fully in charge. A hidden puppeteer pulls the strings. It's fascinating and unsettling. It challenges our sense of free will and control, not only in insects, but across life's spectrum. Parasitism is an intricate dance where one life borrows the will of another. Perhaps the most famous example is Ophiocordyceps unilateralis, the zombie ant fungus. Spores land, penetrate the cuticle, and multiply within the ant. Rather than invading the brain, the fungus forms a body-wide network. It surrounds and invades muscle fibers. At critical mass, control begins. It secretes compounds, sphingosine, guanidinobutyric acid, that disrupt nerve signaling. The brain remains intact, but the body is puppeteered. The ant abandons its colony and climbs. It reaches a height with ideal humidity and temperature. It locks in a death grip that holds after death. A stalk emerges, matures, and showers spores below, restarting the cycle. The strategy evolved with astonishing precision. Another case, the flatworm Leucochloridium paradoxum, the zombie snail parasite. Its life requires a bird and a snail. Inside the snail, larvae crowd the eye stalks as colourful pulsating brood sacs. They mimic juicy prey, advertising to birds. The parasite drives the snail into the open, self-destruction in service of transmission. Toxoplasma gondii, a single-celled parasite that can infect many warm-blooded animals, with cats as its definitive host. It forms dormant cysts in tissues, including the brain. In rodents, infection can blunt fear of cat urine, sometimes even attracting them. A strategy that returns the parasite to the cat to reproduce. Similar effects appear in other mammals, like chimpanzees and hyena cubs. Mechanisms may involve altered neurotransmitters such as dopamine. Up to a third of humans may carry latent cysts. Some studies link infection to subtle personality shifts, but evidence remains associative. In humans, any effects are subtle, not cinematic mind control. Why a human zombie outbreak is unlikely. Biology differs vastly. Many such fungi can't tolerate our body temperature. An ant has 250,000 neurons. Humans was 86 billion. Full control would require hijacking countless intricate circuits at once. Our immune system adds multiple layers of defense. The biological gap is a chasm nature is unlikely to bridge. While a zombie apocalypse is fiction, neuroparasitology is very real, with projects like Zombie Behavior unpacking how control works. Researchers use RNA sequencing and molecular genetics to trace the pathways parasites exploit. Findings may power targeted pest control without broad pesticides, and inspire insights into neurological disorders. The odds of a human-directed zombie parasite are vanishingly small. Body temperature, brain complexity, and immunity are formidable barriers. Real defenses, hygiene, thorough cooking, and healthy pets. Support the science that tackles real parasitic diseases. What do you think? Would you be afraid if a parasite like this could infect people? And what would you do if a real outbreak happened? Tell us below. Please like, subscribe, and join the discussion. Because in nature, the truth is often stranger and far more interesting than fiction.